thanks for making time. I'm pretty sure many of you are already exhausted with the many meetings, the walking around, the discussing with startups, investors, corporates that are all around this show. I'm personally a big fan of Hello Tomorrow show. I've been here for I don't know how many sessions. I think they really do a good production. So today we have a session talking about, of course, deep tech, because that's the whole theme, but more particularly how to be capital efficient and how to be frugal, especially in those days where it becomes quite difficult to raise new rounds of funding because of the global environment. Earlier, there was a session discussing the different funding sources for deep tech startups. And today, in this session, we're going to discuss more about how to be more frugal, more capital efficient, and basically do more with less. So with me on this panel, I actually have a very good group of panelists because they represent different aspects of the ecosystem. So maybe I'll start with Hemai, head of rapid evaluation at X, the moonshot factory of Alphabet/Google. So Hemai, would you tell us a bit more about X to people who are not so familiar with it?
Yeah, happy to. Thank you for the invitation. It's a pleasure to be here. X is the innovation lab and innovation labs that sits within the Alphabet world. Its mission is really to create the next Google-sized business for Alphabet. And some of the spin-outs that you'll see that have come from X, you might know Waymo, the driverless car company, Wing, a drone company, Verily, health tech, digital health tech. So X is regularly spinning up what we call moonshots. But at the very, very early stages, which is my rapid evaluation team, we're going from whiteboarding to prototyping, and our investment thesis is really around trying to propose and kill as many potential moonshots as possible. So our goal is really to take as scrappy and lean an approach we can to testing the viability of our baby moonshots. And so most of the things that we propose, we're trying to kill very efficiently, and then the things that survive go on to live another day and get further funding from the factory and eventually build up into something like a Waymo.
Okay, so thanks, Hemai. So now from Solvay, Peter, tell us more about Solvay for the people who are not familiar with this very large group and your activities in venture.
Yeah, so I'm a partner with Solvay Ventures. That's the venture capital arm of the Solvay group, and Solvay is a global chemicals, well, I have to say specialty chemicals and advanced materials group. Now, it's difficult to explain what we do because it's so many things going into so many applications. But just to give you an example, although you might not know, but I'm sure actually that even today you have been in touch with Solvay materials, be it, when you took a shower this morning, when you were using shampoo, it's probably with ingredients coming from us. When you use your mobile phone, you're touching our materials. If you take your car, if you take a plane, it's packed with our materials. So that's more or less what we do. Now, I mean, Solvay is a very old company. We're actually celebrating our 160th anniversary this year. And what does it mean? Well, it means actually that, for an old company to be still relevant today, you need to reinvent yourself from time to time. And, innovation is very important from that perspective. And that's where we come into play, right? One of the things that Solvay does is through the venture capital arm, through Solvay Ventures, to support innovation, then more specifically within startups, and to make sure that startups can bring their innovation to the market, and that we can contribute to that as well.
Excellent. So Robert, you're more, let's say, a more traditional VC, but what really distinguishes Matterwave Ventures is that you're very specialized in this industrial technology. So tell us more about the type of stage of companies you're looking into, what kind of categories of companies you're interested in.
Sure, happy to do so. First of all, thank you to the Hello Tomorrow team for having us. Great to be here in Paris with all of you. Matterwave Ventures, as you said, we're a traditional financial independent VC firm. Our strong focus is on industrial deep tech. So we're looking for really strong innovations, both in hardware and in software with industrial use cases. And the big mission is really to take European industry to the next level. What do we mean by that? Well, first of all, keep physical value creation in Europe and stop the deindustrialization that has started to some extent with innovation, with new products and new technologies. And second, of course, making it more sustainable in terms of energy consumption, raw material consumptions, emissions, all of what you have, and future-proof it regarding the demographic change. Right, so we need absolutely more industrial automation, smarter automation, because we don't have that skilled labor anymore to the extent we would need it to further grow physical value creation. And yeah, we support companies in the really early stages, sweet spot somewhere between the seed and Series A round typically, but with flexibility. Sometime we go earlier, sometime we go a bit later. All across Europe with typical check sizes between 1 and 4 million euros.
Okay, I think so that shows that there's a perspective of, it's not really too corporate because you're kind of an innovation lab trying to give birth to companies. So you're more like almost a venture builder, even though you're not actually building ventures, you're building internal projects to grow. So it's very, very special situation here. A more classic corporate venture and then specialized industrial VC. Maybe to get the conversation started, since we're talking about how you can do more with less, what is it that deep tech startups need to spend on? How do they spend their money? Why do they need so much capital? So Hemai, in your case, you do the super early stage ideation, but then what costs money in that?
I think deep tech famously costs money, right? It's the difference between building a software company and building something that actually takes expertise, so people, and takes...
It's not all in the cloud.
It's not all in the cloud. It takes equipment. It takes, if you're in biotech, it's consumables. And it takes a lot more time, and time is also money. So all of the above.
Okay. Well, what do you think, Peter?
I fully agree. It's about, in deep tech, it costs a lot of time. Time and money to be spent on, for instance, equipment. And then it becomes a question of what do you spend at what time throughout that journey. So you might start with lab equipment, in our case, then you go to piloting, and then you perhaps to full manufacturing scale, if that's needed. But we can touch upon that maybe a bit later. And that timing is very important, right? Because, it makes no sense that a startup comes pitch to us at seed stage and saying, hey, we want to be the next battery gigafactory. Give us like a billion euros or dollars or whatever to start building that factory. No, you have to go through that journey and to spend wisely at each stage. Okay, so it's more step by step, like from a desktop scale to like room, like closet scale, room scale, early pilot demonstration, early commercial scale. So that every time there's a change of scale, you have a change of capital requirements. Do you see that as well in your portfolio on the companies you look at?
Yeah, absolutely. There's significant spending first to develop the product, services that you need to buy partially externally, equipment that you need to ramp up internally, and then of course somehow to getting to production capacity, be it in-house or outsourced. And then maybe just to add on, and then you need to actually finance the sales cycle, which is typically a longer sales cycle than what you have on some consumer deals.
You cannot just do Google Ads.
Won't work in most of the instances.
most cases for deep tech.
We'll try to support it, of course, to also finance Google for the longer term. But yeah, the sales cycles, especially if you go to the big enterprise customers, they take time. You need the right qualified and experienced salespeople, technical sales leads. All of that takes some capital.
Yeah, so maybe I'll say also a word about what we do. So, at SOSV, we invest in the very early stages of deep tech startups in both climate tech and biology. And our approach is to try to take those scientific founders and help them turn a science project into a business and a company. And our approach is to help them with basically extending their team with in-house experts and lab equipment, lab space. So basically turning some capex and opex that they would have to do if they were on their own into an investment package, essentially, that they can share, shared resources. So we talked about what costs money. Obviously, in deep tech, you can for many companies, you cannot just have like two computer science majors to just build everything. You generally need a variety of skills. And what you talked about in terms of scaling, later you need to bring in industrialization skills, B2B sales skills. So that cost also. In your case, how do you help the companies be more capital efficient in the early stages? So, Hemai, what's your approach at X?
Well, I can speak also to my experience at Breakout Labs. So before I joined X, 10 years, we had a philanthropic fund that was investing in scientific founders, very much like the type that you've just described. And I think one of the reasons we started that program was the opportunity that was presented by the rise of these incubators and accelerators and environments in which scientific founders could go in and not and gain from not having to purchase the capital equipment and all that, but also gain from the mistakes. Because the other thing that costs a lot of money is mistakes. And if you can learn what other people have done and get smart about that more quickly, there's a real advantage to be had. So that was my experience with funding startups. On the X side, I would say one of the things that we really focus on, unsurprisingly, is the opportunity for computation and artificial intelligence to speed up the experimental cycles. Mm-hmm. And so we tend to look for places where we can actually speed up our deep tech development through using simulation as a shortcut.
Okay, so using computation so that you don't need to do like real world, but everything's real, but like physical world experiment in real time, which is a lot slower than running 1 million experiments online in parallel. Right?
Exactly. It just allows you to iterate faster, even though you do obviously have to go back and forth between the real world and the digital.
So to sum up, you made like 2 great points. One is like less mistakes with more guidance. Mistakes cost money, cost resources, cost time. And the second is speeding up the R&D using computation. Do you see other points on the other ways where companies can save costs and be more efficient in the way they use their resources? Maybe, Robert, if you want to start.
Yeah, maybe let's start at the very beginning of the journey where we get a business plan or a pitch deck onto our desks. We try to challenge those founders. Let me paint it a bit black and white on purpose. We see a lot of founders who have been 10 years with a research institute or 10 years with a corporate. And sometimes the initial reaction would be, okay, I'll do a budgeting exercise. I'll just go through everything I want to do, and then I'll add it all up, and then there is 11 million financing need. Can I please have 11 million? Because this is the great technology I want to bring to market.
So they pitch the end goal almost, in terms of financing.
They just add up the list in a very cumulative mental exercise.
Okay.
And I think our first task is to say, this is not how it will work. Nobody will give you that amount of money, most probably. Maybe you're lucky. It's your entrepreneurial task to break this down and to find shortcuts and to reduce the budget, to have intermediate proof points, and then you'll step by step get the financing you need.
So kind of milestone-based financing to unlock more resources?
Yeah, absolutely. So break it down in smaller blocks, and also try to find the shortcuts, try to find the reduction. And that's also what we want to see, right? It's not only about reducing the number, it's also the exercise we want to see, it's the mindset. This is not just another project in your research institute that some state agency will finance. No, this is an entrepreneurial project. You need to think differently about it. Well, and we see a lot of founders who make that step, right?
Would you have an example in mind of like one company who did this particularly well and specifically who came with a mindset that, okay, let's try with everything, asking for everything at the start, and then broke it down successfully with your help and went through those different milestones? Could you illustrate with maybe an example?
Let's take one of the harder ones when hardware is involved and industrial machinery. One company in our portfolio does post-processing machines for 3D printing.
You can give the name, by the way. It's okay.
I can talk. It's a bit of publicity for it. Dimension. Okay. Dyeing like giving color. So they actually give color and post-process the surfaces of 3D printed objects. So when they first had that idea, coming from the application actually, they didn't start a drawing board and say, what's the perfect machine we can envisage to solve that problem. Then they went out into the market saying, we want to find a solution. what machinery is out there that exists already that you can adapt to the specificities of 3D printed parts and the polymers involved. And they basically upgraded existing machinery. So they saved a lot of R&D, they saved a lot of CapEx by finding machines in the market and adapting them before. And then they had hundreds of machines in the market and got financing from us and others. And then they went back to the drawing board and started to develop their own machines with completely new approaches of chemical smoothing, which was not available at all. So it's not like you only need to do the low-tech stuff, but maybe there is a lower tech and lower CapEx involved first step, get into the market, prove your point, build a company, drive revenues, and then in parallel, you can do the harder stuff.
So if we think about them in terms of like reaching a milestone, how would you define the milestone that they reached with this first machine repurposing? Was it a technical milestone? Was it a like feasibility, a business proof point? What did they actually achieve there?
Rather the business proof point. I mean, saying there's a market, we're able to sell industrial machinery to customers. And
with the repurposed one already? Okay.
Yeah. Well, repurposed, yeah. They went to the machine builder and adjusted together with the machine builder.
So they specified modification?
Yeah, it was a co-development with the machine builder, but on the basis of something that exists already that can be produced at reasonable costs. And they proved that they can actually bring something to market, get it mature enough that customers will buy it in an industrial setup, right? It's something you need to achieve. And that then they can build up a sales channel, they can scale revenues, and that attracted quite some capital and gave them the room to advance on the rest of the R&D pipeline, which is completely new processes, even much more proprietary technologies and own machine building in the end. Okay, so build the V1 before building the V2, which is the one that they want to do, but they can't do from the get-go. So I'll move on to Peter. Like, so in totally like different area, because we're talking about like machineries and hardware. You're more chemistry. How do you see that adapt to the categories of companies you're working with? Like, what kind of efficiency can they find early on?
Well, there's many things that can be done, right? And I've heard some interesting thoughts coming from you, Robert, especially around the challenging part, but more specifically about us as a large corporate. How we try to help startups to be more efficient is to offer, our help, basically, right? Services and can take many forms, right? We always try to look case by case with the companies we are invested in, how we can help them. One example is that we can help them to scale up, for instance, some of the materials that they use in the solution that they want to bring to market. So they don't have to invest themselves in, equipment or in know-how or people to do that. So this is one way. So joint development agreements is typically a form that it can take. It can also be just plain tool manufacturing, right? That's maybe a less preferred model because there's not that much value capture in it for us. But we always have this conversation with our startups, how to be able to help them so that they can be quick to the market with as little money as possible.
So you're kind of almost bringing like the cloud computing, but in the form of manufacturing resources
exactly,
so
or
they
R&D.
Kind of fabless.
Yeah, or R&D, for instance, right? Because it's all about optimization, right? And I also heard about AI. I mean, AI is definitely one that we will see more and more of in the coming years. We are actually invested in an AI company in the US called Noble AI, helping to speed up R&D processes to, not just for startups to go to the market quicker, but also for large corporates like Solvay, basically.
Okay. Yeah. Hemai, many of the projects at X touch also the physical world, which is, not the usual world of Google on services. So when companies, like you finance a number of projects in the energy space, for instance. So how does it work? I understand the cloud part, but can you also support those companies figure out how to be more efficient on the physical part of the projects?
So we are very lean when it comes to building the physical parts of our projects. I think there's I'm not sure if the the visuals are there on our website, but there's a company, or there's a project, X Project Mineral, that is an ag data company that we started a few years ago, and it's public, or it's public on our website, not publicly traded company. But Mineral is an ag data company or ag data project that started out as a rover going in through strawberry fields and monitoring soil, leaves, et cetera, But the very, very first prototype of it was essentially two bicycles with like some cross arms sort of jury rigged together and some like a camera sort of taped onto that, and that was actually what we call the V0 crap version, which the whole point was to build something as cheaply as possible to get it out into the real world, to figure out what we actually needed to build as opposed to building something fancy up front. So I think there are two sort of threads I picked up on what Peter and Robert were saying. There is this element of the scientific or the technological development that has to be absolutely rigorous and done well and to the highest standards, and you need to figure out how to do that quickly. But then there's also the piece of not wanting to do it just because it's an academic exercise. And I feel like a lot of technical founders come in with an academic mindset of having to dot all the I's and cross the T's. And so for us, it's very much a part of our culture within X to try and separate those things out and do the V0 crap version where that's applicable to answer the business questions, the business milestones that you need in the technology development. So we're very strong on that. The other thing that we talk a lot about within X is the choose your monkeys and battle and choose the correct monkeys for your project. And by that I mean if you're asked to have to create a monkey on a pedestal reciting Shakespeare, a number of people would be tempted to work on the pedestal first because that's a very clear thing to do, when you really should be figuring out, is it at all possible to teach a monkey to recite Shakespeare before you even think about doing a project or a venture like that?
And well, can you think of an example in one of the projects that went through the labs that illustrate this shift of mindset of the monkey versus the pedestal? That maybe founders arrived and they were really focused on one aspect, maybe thinking the other one was kind of sorted out, and then help them reshift priorities?
Well, we face the problem every day. I can talk about one project that we also publicized, which was called H2E, and it was trying to give 2 billion people access to clean drinking water that don't otherwise have. And so the project was designed to try and capture atmospheric water from the air, essentially, an atmospheric water harvester, solar powered. And we actually built a prototype. We had a variety of parameters to try and, would it work in these humidity conditions? Would it work, at this cost point, et cetera, et cetera, et cetera. And so we built a version and got it out into the field, and it actually couldn't produce enough water to meet the real needs of a household for a period with a footprint that was sort of plausible in that context. And so essentially we kind of built the thing that we could build as efficiently as possible and got it out into the field thinking that it was meeting all of our criteria, only to discover it wasn't actually meeting the criteria that the people needed to adopt it.
And do you feel that's something that could have been kind of anticipated, calculated, simulated, or it needed to be tested?
I think at a certain point you just need to get out there and interact with the people that are going to use it, and you can simulate all you want, but at some point you just have to get out there.
Okay. I'll move on to a kind of related topic, which is to describing like getting the first prototypes done. And one of the reasons we set up our own labs is to actually being able to help speed up the prototyping cycles and lower the cost of prototyping cycles. So we have wet labs in San Francisco, New York. We have a hardware lab in New Jersey and in China, in Shenzhen, the middle of supply chain. And a lot of companies that came to work with us, that we invested in, were very surprised that instead of doing like one iteration of the hardware thing every month, they could basically get new PCBs, parts in a matter of days, sometimes hours, and they could, at a much lower cost, and then run multiple attempts, multiple experimentations in parallel. So that leads me to that question of, are there ways to kind of speed up those iterations that are necessary to get to the MVP that can eventually be put in the hands of customers? So Robert, do you have like examples in mind of companies that found clever ways to prototype faster at lower cost?
I think there's an amazing number of tools out there, and back to the point of compute and how can we simulate, with which you can save a lot of time. And it's not only science fiction or what will happen in 10 years, but it's available now, right? You might have to tweak it a little bit. One of our companies is building robots with proprietary kinematics, and they use AI to build the best kinematics, sort of the best to optimize the angle and the geometric position of the levers. So they run that on software. They simulate, I don't know, 100,000 options and try to advance to the best ones directly before building the first physical prototype. We're investing even in this field of R&D tools using AI to speed up product development processes.
Tools for tools.
Tools for tools, but I see them in action in some of our portfolio companies already. And maybe you need to build up the skills, you need to invest, right, in making use of those. They're maybe not plug and play yet to exactly what you're aiming to do, but it's out there.
Okay. Peter?
Yeah, maybe to add to that, right, iteration. I think the nicest way to iterate, and I have a good example for that in our portfolio, is to, to basically do it with a customer who is paying, right? So, and then it comes to, I'll give the name of the company that I have in mind. It's 90 Labs. It's a Swiss-based company, Switzerland-based company. What they're doing is 3D printing of composite materials. So the really end goal is to make very high performance parts that can go into aerospace, very high demanding applications, aerospace applications. But in the end, it's about defining what is your minimal viable product with which I can go to the market. And it's maybe not in aerospace. So here in this case, being in Switzerland, what was the logical thing to choose? It's watches. So what they did is they had this collaboration with a watchmaker based in Switzerland, and they 3D print with composite materials the watch case, right? That's not a very high demanding application, but nevertheless, it gave them the opportunity to learn about their machine, to see how it behaves in mass manufacturing, to learn from that, to then build to their next step of going into the aerospace market, basically.
Okay, so prove it with a product with like a lower, higher tolerance. Okay, well, it's good they went to watches, not chocolate, because I'm not sure about composites in Hemai, how about you? So you mentioned already ideas around like using computation to speed up R&D. Do you see other ways to accelerate prototyping and lower the cost of prototyping on the physical world part?
Well, I think finding the right CROs, honestly, not having to build everything in-house. I mean, these partners are one way, but actually there are CROs that know how to do a lot of things.
Research organizations that are basically to whom you can delegate part of the R&D?
Right. You know, there are animal labs that have all the facilities. I mean, some of them are more expensive than others, but I think that there can be great efficiencies to finding the right CRO partner to speed things up.
Okay. So we talked about like many ways to reduce costs. We talked about iteration. I think it's worth maybe talking briefly also about the sources of financing. I know that was part of a previous session, but I'm not sure everybody attended it. So it's good to speed up and spend less, but if you can also find ways to be capital efficient and like on your like your cap table, your funding efficiency, finding ways to get non-dilutive financing. Those are all things that are relevant to deep tech startups. So maybe broadly speaking, if you can mention the first ideas when you meet a deep tech startup, say, okay, you can find funding from this, like Robert, what are your go-to sources of funding for deep tech?
Well, our main objective is equity efficiency.
Yes.
Picking up your point, okay, let's spend less, but then where do we get it? Whatever we need. So part of it will be equity from VCs like us. Once we're in the same boat, right? Then we want as little dilution as possible, and honestly also as little fundraising effort as possible.
So it sounds like if you don't want too much dilution, you want less rounds, or you want later rounds, and maybe not too big rounds, right?
Exactly, all of that. Because there's also management attention, which goes in fundraising, right?
That's right.
We'll talk in a bit about celebrating the very big rounds and how useful that really is. But to your point, we try to encourage our companies to think about financing from the customers, prepayments, joint development projects, whatever you can do to get some money from your customers early on.
The best money, actually, from customers.
It's not for free. You'll have to deliver something for it, but sometimes you can sell a little bit of know-how, right, to the right customer for a very specific application where you're not giving away your core IP, but you're selling some know-how, or you get prepayments or joint developments. Same thing on the other side. What about your suppliers? The suppliers will hopefully have big business in the future with what you're doing. Can they invest, cut a special deal where the first parts are much cheaper, and then you'll pay over time? And of course, grants. I think Europe has made some big steps forward in making available pretty sizable grants and even equity participation then from governmental money.
Okay, I'm going to jump to Hemai actually for that same question, because your setup is very particular. You're trying to build internal projects that can grow into large businesses within the group. So you're thinking about financing is probably a little bit different unless the project becomes a spin-off, right? So how do you unlock capital internally, and do you look for alternative sources of financing? How does that work?
Most of our projects have been internally financed at the earlier stages, and so for us, it's about talking to stakeholders and identifying what the milestones are that would cause them to get on board. So it's not that different from a startup looking for venture capital and going out into the world saying, what are the milestones that are going to make sense? And
so it's not a rich uncle that you can just keep asking.
Right? It certainly is not. We are lean and mean, and I would say that we haven't had the opportunity to bring in grant funding. We can do partnerships to do sort of R&D development and sort of early customer traction. I wanted to caveat the notion of grant funding as being an entirely capital efficient or source of non-dilutive capital. It is, but I feel as though I've seen this pattern repeat over and over again where startups will try and get in as much grant funding as they can, whether or not it's actually targeted towards building the business in the most efficient way, and that can sometimes result in a kind of bloated organization that's not actually driving towards business goals. So I wanted to caveat the notion of grant funding to be targeted to the business purpose.
And in your case, Peter, what are the sources of capital you try to help the startups with?
Well, I think most of it you already heard, and I think those were very good points, especially about grant funding, that you need to be very careful that it serves the purpose and it's not, defocusing. But what I specifically like about these sources of, let's say, funding in addition to equity funding is that, and I've seen that with the pandemic, right? The equity financing tends to be cyclical, right? There are periods where it's more difficult to attract capital, and if then you have these other sources of funding like grants, they can help you bridge those more difficult periods, and in that sense, it's a very nice addition to equity.
Yeah. In our prep call, actually, Robert, you mentioned that there was this tension between as an investor, as a founder, wanting to raise large amounts so that the company has lots of resources and, in a way, can do more, but also the need to be conservative also on the equity front and be careful about how much capital you bring in, what actually really matters, and what is good news for the company. So do you want to say a word about this tension between conserving equity and trying to become a unicorn and raise super large rounds?
Well, it's pretty straightforward, right? In the end, we need to deliver cash-on-cash returns to our investors. We love to do, in the meantime, paper returns. Big rounds deliver typically large evaluations, and it's nice paper returns. But in the end, we want to deliver cash on cash. So what matters is how big is the exit, and multiplied by what part of the pie do we actually own, right? And the larger the rounds and the more rounds, the less we own of the pie. So it's therefore not necessarily only optimizing the number and size of capital, but rather do it in a capital efficient way, right? And build the biggest possible company with the least capital possible, as I think we have in the headline. And yeah, I think there's a bit of a tension that, of course, it's important to build our European ecosystem and stop thinking small and only building small projects. No, we want to build big projects. But the individual founder, I think his objective should be to build the biggest thing with the least capital possible, right? And I think the celebration of the very large rounds and the celebration of the unicorn valuations, it defocuses sometimes slightly what's actually the objective. Right?
Yeah, I've seen examples of companies that end up raising like many convertible notes on the seed one, on the seed two, then they get to that stage where even though they raise a fair amount of capital, the founders and the initial investors are so diluted that they're almost feeling like they're not the owners of the company anymore. And in the particular case, a later stage investor had the good sense of preparing a large equity pool that they redistributed partly to the founders, but that ended up diluting again everyone who came before. I have one question also for Hemai about, because in some cases you decide to spin off some projects. What kind of project do you keep inside Alphabet, and what kind of projects do you prefer to spin off?
That actually changes as our business strategy changes. So I think I can't give a general rule for the kinds of projects that we'll be interested in at any one time, but we have in the past spun out projects. We had one that was a dandelion, which is a geothermal energy.
Yeah, residential.
Exactly. Malta is a salt, a thermal
solar
salt.
thermal.
Exactly. So we've spun out, typically when we look at projects within X, we're trying to build, as I said, these alphabet level businesses. And quite often we'll find that on this path to a moonshot, actually, we're not going to reach that. Internally, we don't think we have the resources to allow it to reach that kind of potential. And so it will be better served by being out in the world working at other kinds of capital around it. So it's a decision that's made on a case-by-case basis.
Okay. I see we only have a couple minutes left. I saw some questions here, but it looks like I don't have the questions for our session. I think this is the previous session. So I'm just going to maybe close up with a couple of quick questions about what not to do as a deep tech founder trying to be frugal. Is there or trying to be capital efficient? Are there mistakes? Like, for example, trying to really do everything at so low cost that it takes forever? Or like, what are things you've seen that you said, don't do this? I know it looks like a good idea, but it's not. Anything that comes to mind along those lines?
I mean, our use cases are in the industrial world, so what you typically need is reliability and quality of your product. I mean, we spoke a lot about do it with less. Don't compromise on reliability and quality of your product if you sell to industrial customers. Okay. That's a very short-lived game.
Because you're going to get just one sale.
So yes, I'm talking about shortcuts and equity efficiency, but on the other side of things, right? Not on making your product worse or shortening product lifetime. No, think about how to spend less on the R&D equipment or on the outsourcing services that you need. But keep your highest standards on the product, of course.
To quote a famous motto from old Silicon Valley was, move fast and break things, cannot break too much, right? Better reliable things. How about you, Peter? Any ideas on that?
Yeah, we've had cases, for instance, when fundraising is a bit, slower than expected, that companies were trying to cut corners, have too many corners, basically, where we had to say, well, please don't do that, because you are really entering into risky territory that, if things do not work out like you are predicting, then your timeline is going to be, going up exponentially, because you know, these things. Well, when I'm thinking about now, there's, you know, like this sequential thing that needs to go on. If one piece of the chain is, you know, is missing because you made a shortcut, then your whole chain falls apart. Well, don't do that.
Okay. Protect the core. Okay, Hemai, you're going to have the final words on this. So, what would you advise?
Get advice from people who've done it before, because they're the ones that are really going to know what corners can be cut and what can't.
Excellent. Well, I think, yeah, we're going to wrap it up. So thank you very much for insights. Thanks for your attention. Thank you.